right, hello. Hey, we're gonna pick up where we left off with the unit circle. I know the unit circle can be a little bit overwhelming with trying to figure out how to fill in all these blanks, but I think once you spend a little bit of time with it, you do notice that there are a lot of patterns. And so we're going to start on this notes page, which initially had a blank unit circle on it. I went ahead and filled a few things in just to save a little bit of time. You need to be able to fill in all of these angle measurements on your own without looking back at anything. And again, remember we talked about a pattern adding 30, 45, 60, and 90, and then when you spill into a new quadrant, you're adding 30 to 90, 45 to 90, 60 to 90, and then 90 to 90. And then you repeat that same process, adding to 180, etc. Okay, we talked about how we got the coordinates of each of these 16 points by creating these different 30, 60, 90, and 45, 45, 90 triangles. Important and a really good idea to draw in these kind of signs to remind you in each of the quadrants. But at the 30-degree mark, we said if you made the triangle, you would get the long leg, the horizontal leg would be square root of 3 over 2. The short leg would be 1/2. Okay. Then we talked about a quick way of just visualizing, reflecting that point over into quadrant 2. And because the x is negative, we're just going to make that minor adjustment there. Okay. Just got to be careful when you talk about flipping it down. Picture folding your paper on the axis where that would land. And then you keep the numbers in the same order, make a minor adjustment to the signs, okay? So this part we had talked about before. Okay, so just you can see how just in me getting that 1 point, I was able to quickly get the other points. Actually, I typically like to go through and fill in the 4 points that are directly on each of the axes. So I'm going to do that first. Remember we said the radius of the unit circle is 1 unit. So this is out to the point 1, 0. This would be up to 0, 1, -1, 0, and then 0, -1. Okay, I'm going to skip the 45 point for just a second. I'm going to jump to this because this is the other 30, 60, 90 triangle, only the values are flip-flopped because now the short leg is the 1/2 and the long leg is the square root of 3 over 2. Okay, just flipping these over, making these small little adjustments with the signs here. Okay, it would be a good idea for you to, I'm going to try to, whoops, that is not negative. Sorry. Post like an extra blank unit circle for you to go ahead and attempt to try to fill in on your own. Okay, and then the 45, 45, 90 triangle, we discovered that each of the legs, which were both the same length, were, once we made it a simplified radical, were square root of 2 over 2. Okay, so I'm going to fill these in. You can see how quickly then, once you kind of get the pattern down, how you can sort of fill all of these in pretty quickly. So the part that we did not talk about on the other notes page was how to get the tangents. I guess one thing real quickly that I do want you to write down is it is very important that you remember that cosine is the x coordinate of the point while sine is the y coordinate. And here's my best way to try to help you remember this. If you were to alphabetize these two trig functions, cosine and sine, you would put obviously cosine first, and then sine would come second. If you think of it in that order, that will help you remember that cosine is the x coordinate of each point, and sine would be the y coordinate anytime you're asked any of these angles here. Okay, we're going to review a little bit of that today as well, but I want to look at tangent with you here real quick. Okay, we know that tangent in a right triangle is opposite over adjacent. Okay, well, when we're making these coordinates here, we've established that if you had your triangle drawn, the opposite leg, which is always the vertical leg, is always your sine value. Okay, so we're saying the opposite leg is always the sine value, and then the adjacent leg, which is always your horizontal leg, that is always the x coordinate or your cosine value. Okay, this is a trig identity. You'll learn a lot of these next year in pre-calculus. This is the most simplest trig identity, which is the fact that tangent is equal to sine divided by cosine. And if we were to really break it down, you could get tangent by taking the y coordinate of your point, since that's sine, and dividing it by the x coordinate of your point, since that's cosine. So let's see if we can't do a few calculations here to try to get what tangent is for each of these. And I'm going to start at each of the 4 points that are on each of the axes. Okay, keep in mind here what I have highlighted. Tangent is, I'm even going to highlight this part here. It's the y coordinate divided by the x coordinate, which is a little unnatural. It's like you're going to have to go from right to left here. Okay, so let's look at the 0 degree or the 360 degree mark here. Okay, I can see that here's my 2 values, 1 and 0, but for me to do tangent, I have to do the y coordinate divided by the x coordinate. So I'm doing 0 divided by 1, which that just reduces to 0. Okay. I want you to jump over here to 180 real quick. You can see that if I did the y coordinate divided by the x coordinate, I get 0 divided by -1, which is also 0. But if you look up at 90 or even down at 270, when I do the y coordinate divided by the x coordinate in each of these situations, now my 0 is in the bottom. And that's something in math that if you were to divide a number by 0, your calculator gives you an error. And so we're going to put UND, short for undefined, because we're getting a 0 in the bottom. Okay, so tangent is 0 at 0 and 180, but tangent is undefined at 90 and 270. Okay, let's follow the same logic. We're taking the y coordinate, we are dividing it by the x coordinate. So for 30 degrees, I'm going to take the y coordinate, which is 1/2. I'm going to use this division symbol with the 2 dots. I'm going to divide the y coordinate by the x coordinate like that. Okay, now when you divide 2 fractions, you're supposed to multiply by the reciprocal of the second fraction. Okay, I'm just going to erase this to give a little bit more space here. Okay, and then I can see that these 2's would cancel. That would leave me with 1 over the square root of 3, but I know I'm not supposed to leave a square root symbol in the bottom. So if I multiply across the top, I get square root of 3. Across the bottom, I get 3. So this is what I'm going to fill in right here on the line for what tangent of 30 degrees is. I'm just doing the y coordinate divided by the x coordinate. Okay, and then I'm going to flip that over into quadrant 2. And when I flip it over into quadrant 2, I'm simply going to change the sign and make that a negative. And the logic there is that in quadrant 1, the y and the x coordinates are both positive. So a positive divided by a positive. All the tangent values in quadrant 1 and all the tangent values in quadrant 3 should be positive, but in quadrants 2 and 4, the tangent values should be negative. So when I flip that down here, it just kind of alternates. It goes from positive to negative to positive to negative there. Okay. All right, I'm going to jump to the 60-degree angle here real quick. Okay, and again, we're just going to do this pattern y coordinate divided by x coordinate. So I'm going to take the y coordinate at 60 degrees. I'm going to divide that by the x coordinate. I'm going to change that to multiplying by the reciprocal. I'm going to cross off the 2's, and I basically get square root of 3 over 1. I'm just going to write that as square root of 3. Okay, you can see I'm flipping this down into each of the other quadrants, and I'm just adjusting the signs, alternating positive, negative, positive, negative. Okay, lastly here, now look at 45. If I take the y coordinate and I divide it by the x coordinate, I'm taking a number and I'm dividing it by itself. I don't even really need to show that math. If I take square root of 2 divided by 2 and divide that by square root of 2 divided by 2, I'm going to get 1. Okay, and then over here, -1, 1, and -1. Okay, now my unit circle is complete. Let's see if we can use it to answer some of these questions here on the next page. Okay. So we want to keep in mind here, we're really just going to now pull our answers directly off of the unit circle. So when you're doing your homework, you want to have one of these completed unit circles right in front of you. And you're just going to do this. For part A, when it says sine of 900 degrees, I think we had some of these. I feel like some of these were on yesterday's notes page. This one. Let's go ahead and try. I don't know if this one was or not. I don't think it was. Okay, so let's try C. We're going to do cosine of, now there is no -930 on the circle. So you have to just keep adding 360, add 360. Just keep doing that until it falls on one of the angles from 0 to 360 in our unit circle. Okay, once you got, and by the way, all of these are going to fall on one of those 16 points on the circle. Okay, every time these problems are going to be like that. This is a cosine problem. Okay, so I look back, I need to go to 150 on the unit circle. So I'm going to scroll back here. I'm going to find 150 degrees, and because this is a cosine problem, I am grabbing whatever the x-coordinate is on the circle at 150 degrees, and that is what I am writing down. Looks like that was negative square root of 3 over 2. I'm done. That's my answer. Okay. Now for secant of 960, I don't know if this one was on yesterday's or not. Okay, this is wanting me to look at 240. I got 240 just by subtracting 360 a couple times, only I see that, okay, this is a secant problem. So I have to remember secant is the reciprocal of cosine. So I'm going to go to 240 on the unit circle. Okay, so let's go find 240. Okay, here we are. This was a secant problem, though. We said secant is the reciprocal of cosine. So you're going to grab the x-coordinate, but you're going to flip that. Instead of writing negative 1/2, you're going to write down that your answer is negative 2. Okay, let's do a tangent problem here. We have to subtract 360 probably about 3 times on this 1,110 to get it whittled down here. Once you do that, you see, oh, okay, this just wants me to go to 30 degrees. It's a tangent problem. Now, fortunately, if you got your unit circle filled in, you have the tangent values there. So go to 30 degrees. Whoops, I feel like I erased something here. I think this is supposed to have a 3 underneath it. You're going to go to 30 degrees. You're going to see, oh, tangent is the square root of 3 over 3 at 30 degrees. So I'm going back here. I'm going to fill in that tangent of 1,110 would also be square root of 3 over 3. Okay, let's try a cotangent problem though. Okay, cotangent of 900 degrees. We're going to subtract 360 a couple times. That gets us at 180. Okay, so you're going to go back to the unit circle, find 180 degrees. Now, you can grab the tangent value, which is 0, but remember, this was a cotangent problem. Now, I want you to think about how 0 looks as a fraction. 0, would be 0 over 1. But if I'm going to do the reciprocal of that, because this is a cotangent problem, then I need to do 1 over 0. If I'm flipping that, then I'm really going to say that my answer for cotangent of 180, undefined, is what my answer is. Okay, undefined. So here's the key. Anytime you do the reciprocal of 0, it becomes undefined. Anytime you do the reciprocal of undefined, those become zeros. Okay? Now, these last few just are in radians, which obviously we're not writing these radian measures on the unit circle. You can see a few of these that I already did for you. You want to change this out of radians and into degrees. That has to be your very, very first step. So if you change that out of radians and into degrees, you end up initially getting that 3 pi is the same thing as 540 degrees. Okay, then you're going to have to subtract 360 off of 540 degrees so that you know where you're looking on the circle. We're going to go to 180, and this is just a basic sine problem. So you're going to go to 180 on the unit circle. Remember, this was sine, and we said that sine is the y-coordinate. So you're going to grab that y-coordinate, which is 0, and that's what we're writing down as our answer for that problem. Okay, I'm just going to jot down what the answers are for these next two in case you want to try them. 5 pi over 2 converts to 90 degrees. This is secant, so you have to think about what that's the reciprocal of. The answer should be undefined. And on this one, this ends up initially, I think, being cosine of 450, which then has you looking at 90 on the circle, which is just 0. That one's pretty easy. But this one is definitely worth you guys seeing if you could see how I got undefined for that. Okay, your homework assignment is on this worksheet here. I only want you to do the odds, and then tomorrow you're just going to do the evens for that. So there will be no video tomorrow. Okay, thanks you guys so much.